Okay, today we're going to talk about naming binary ionic compounds. We talked about this a little bit yesterday at the end of class. So there are 3 rules. Number 1, name the monatomic cation present. So this is just the name of the element. Now please remember that a cation has a positive charge, and we're dealing with a metal here. Okay, so for example, if I have sodium, the name's going to be sodium. If I have a silver, it's going to be silver. If I have calcium, it's calcium. So the name does not change. The second thing we do is name the monatomic anion present. And just remember that an anion has a negative charge. And these are nonmetals, because nonmetals, to become more stable, want to gain electrons. And when we gain something negative, we get a negative charge. Now in these guys, we're looking at the nonmetals on the periodic table, and the name of the element changes to "ide." So for example, if I have nitrogen, it's going to change to nitride. If it's fluorine, it's going to change to fluoride. If it's oxygen, it's going to change to oxide. Okay, so let's just do some examples after we talk about this third rule. The third rule is that polyatomic ions always keep their own name. So for example, CO3 with the 2 negative charges carbonate, it's going to stay as carbonate. OH negative, get my pen to work. OH negative, the name of this is hydroxide. So you're never ever changing the names of these polyatomic ions. They always stay the same. Okay, so let's name each compound. So this first one, the name of our first element, Na, is sodium. So we're just going to keep its name the way it is. And then fluorine is going to change to fluoride. So we're changing the ending to "ide." Okay, this one right here, Ca, is calcium. And the O, the oxygen, is going to be changed to oxide. Number 6, again, we have calcium. And if you notice right here, we've got PO4. When you have a formula and you have 3 or more elements, different elements, you are for sure going to have a polyatomic ion. So you're going to look for this name by looking at the polyatomic ion list and finding PO4. And the name of that is phosphate. So this is just called calcium phosphate. Okay, our last one, Ag, is your metal or your cation. That name is silver. And then, oh, look at here, we have 2 capital letters together. That means we've got a polyatomic ion, and the name of NO3 is a nitrate. So there we go. There's all your names. Okay, so just pause the video, take a moment to check what you think the correct name for MgBr2 is. Okay, good. I hope you got C. It's magnesium bromide. Let's do another one. Again, pause the video. Okay, on this one, it is D, potassium nitrate. Okay, on your homework on page 7, all the ones I've circled here, you can now do from what we have done. Okay, let's continue on writing rules for writing formulas for ionic compounds. So go to page 4 in your packet, and I want you to go ahead and write this down in the little box. Okay, so this one we're going from a name like sodium chloride to the formula, which is NaCl. So the first thing you're going to do is find the charge for each ion, so the cation and the anion, and then you're going to swap and drop the charges. And you do this because we want this to be neutral. So the reason we swap and drop is to make that formula neutral. And then the third thing is we reduce to the lowest ratio. Now we don't really do this very often because usually they already are at their lowest ratio, but this is what we call an empirical formula. Okay, so let's do this. It's like a dance party. We're so excited. All right, so let's do these examples. So first of all, we've got calcium and bromine. So we're going to go ahead and do their charges. So calcium's charge is 2+ because it's in group 2. Bromide has a negative charge. So what happens here is we have our charges, and these charges don't cancel out to become neutral. So we're going to swap and drop. So this right here, that charge would go down there. And really what we're taking is just the number, not the charge. And that 2 would go down there. So when we write this, we write it as CaBr2. So you can kind of think about this as math. Okay, if we go back to here, we have a +2 and a -1. So in order to cancel this out, we have to have 2 bromides. So we have 2 bromides, they each equal negative charge, and then we have this +2 for calcium. So we can really just do an algebraic equation, but it's so much easier to just do what we call swap and drop. So let me show you what this looks like. Here's our final formula. If we break this back apart into ions, this is telling us we have 1 calcium. And notice we don't take the 1 down to show it because it's redundant, because it's already being recognized as 1 because of the calcium. And then we've got 2 bromines, and so when we write these out and we look at their charges, this is what we are given is 1 calcium ion and 2 bromide ions. And then if you look at the charges, look what happens. You have a +2, a -1, and a -1. Together, this is neutral. This is why your swapping and dropping works. Okay. If you've forgotten about the charges, remember we talked about those the other day, and we said that group 1 had a +1 charge, group 2 had a +2 charge. That's where I'm getting those charges. Okay, let's go ahead and do the second one. The second one is magnesium. It has a +2 charge. Nitrogen has a -3 charge because nitrogen's in group 15, so it wants to gain electrons. So again, do these charges cancel? The answer is no, and so we're going to swap and drop. And again, when we swap and drop, we're just taking the number down, not the charge. And we're doing what's opposite on the top. So this one we have 3 magnesium atoms and 2 nitrogen to make that a neutral formula. Okay, the next one is aluminum and sulfur. So aluminum has a +3 charge. Sulfur has a -2 charge. Again, these aren't canceling, so we're going to swap and drop. So we have Al2S3. Okay, this last one, pause the video and see if you can do this one on your own. Okay, we're back. Potassium has a +1 charge. The chloride has a -1 charge. So notice here that a +1 and a -1, these cancel. And so you don't have to swap and drop. So KCl would just be your final answer. All right. So there they are. You can see in the color the swapping and the dropping occurring. Okay, let's do some more. So this is on page 4, number 3. Okay, the first one, calcium fluoride. So let's do our symbol and our charge. And remember that these are always metals first, non-metals second, and that's because we're dealing with ionic compounds. So calcium is a Ca, has a 2 positive charge. Fluoride is F with a -1 charge. These charges don't cancel, so we're going to swap and drop. So we get CaF2. The next one is sodium oxide, Na with a +1 charge. Oxygen has a -2 charge. Again, those don't cancel, so we swap and drop. So we get Na2O. The next one, aluminum, has a 3 positive charge. Phosphate is PO4 with a 3 negative charge. And indicator right here, if you have an 8 or an ite ending, it's going to be a polyatomic ion. So that's where we got that PO4 with a 3 negative charge. Okay, these right here, these cancel. And so we're just going to write those a little closer to each other. So this is just AlPO4. Okay, this one is different in your notes. So I'm going to go ahead and change this. This one is aluminum sulfate. Okay, so let's go ahead and do this one. Aluminum is Al3 positive. We know that from up above. Sulfate, it has an 8 ending, so you're going to go to your polyatomic ion sheet, and this is SO4 with a 2 negative charge. Okay, so again, these don't cancel. So that 2 is going to come down here and be after the aluminum, and that 3 is going to come down here. Now, here's a little thing that's happening. Let me just write this out. Okay, when I put that 3 down there, it looks like we have 43 oxygen, and that's not correct. So in cases where our charge is a 2 or greater on the positive side, or if we have a charge that's a -2 or lower, like -3, -4, and we're swapping with something that has 2 or more atoms, we have to use parentheses. So for example, on sulfate, okay, this SO4 with a 2 negative charge, this has 5 atoms, 1 for sulfur and 4 for oxygen. So when we add that up, we get 5 atoms. So we have to use parentheses because we're swapping it down with this charge that's 2 or greater, that's greater than 2. 2 or greater. So here's how we would really write this. We would write this as Al, bring the 2 down from the sulfate, then in parentheses we do SO4, in parentheses 3. So what this is telling us is that we don't have 43 oxygens like this one's telling us, right? This is wrong, okay? What this is saying is that we have 2 aluminums. So if we write this out again and look at their charges, we've got 2 aluminums, and we have 3 sulfates. And we also want to use those parentheses so we can tell that this is sulfate. Okay, so notice your charges, +3, +3, that equals a +6, -2, -2, -2, equals a -6, those two cancel out. Okay, let's do this last one on the page. Magnesium hydroxide, magnesium is a +2, hydroxide is a -1. Again, these don't cancel, so we're going to swap and drop. Okay, we have the same thing happening as we did up above. So we have a 2, and then we're dropping it down to hydroxide, and it has 2 atoms, so we have to put parentheses with the 2 on the outside. This is not the same as when we go MgOH2, because that just is showing us we have 2 on the hydrogen when we should have 2 oxygens as well. Okay, so there's your answer there. All right, there's our lovely answers. Bloop, bloop, bloop. Okay, in summary, ionic bonds involve the transfer of electrons. Each formula in an ionic bond has 2 parts. They have a positive part and a negative part. Only the lowest ratio formula is used, which is usually what you have anyway. We never use 1 as a subscript because it's redundant. If I say Ca with a 1, Ca means 1. I don't need to write it again. And then, this is very important, never write charges in the formula. When we swap and drop, we do not take the charges with us. We just take the number because we're making it neutral. Okay, the next few slides you're just going to practice. So you can go ahead and pause me as I go through, and then it has answers, so you can go ahead and do that. Then on page 8, these are the questions you can do on page 8 as of what we've covered right now. And if you have any questions, please let me know. If you'd like me to check anything, please let me know. And I hope that was helpful. Good luck with everything. We miss having you in class, and adios.